Assalamu alaikum and good morning everyone. My name is Mahmoud Rafi. I will be presenting module for assignment 1 which is ROV systems schematic diagram. Today I would like to talk about electrical block diagram, hydraulic block diagram, electrical schematic diagram and hydraulic schematic diagram. Firstly, I would like to present electrical schematic block diagram. It consists of genset, also known as a generator set, which is a combination of diesel engine and electrical generator. Genset will supply power to hydraulic power unit and control van. Then from the control van, it will go to umbilical winch, then tether management system, TMS, and then ROV. Now, I would like to present hydraulic schematic block diagram. The diagram starts from motor, then it goes to pump, then from the pump to the filter, and then from the filter to TCU, tether control unit, and from TCU it will go to mechanical compensator, hydraulic control unit, and fourth thruster. From the TCU it will go to fourth thruster, from there it will go to mechanical compensator. From TCU to mechanical compensator will go to water filter, and from TCU to HCU will move the manipulator and it will go to water filter. At water filter it will filter the water from hydraulic oil in the system. Then from the water filter it will go to the main compensator. Then from the main compensator it will go back to the pump. That's how the cycle will continue until ROV stops. Now I would like to present electrical system schematic diagram. In this section it will cover genset, control van, HPU, umbilical winch, TMS, tether management system and ROV. The power from genset will give 480 volt AC. The, the, the power will go to transformer at the control van. The power will step down from 480 volt AC to 240 volt AC 3 phase. This transformer will activate light, air conditioner and control rack. So we assume that this transformer will act as a domestic transformer. The power supply from genset will also step down from 480 volt to 440 volt AC. So this voltage from transformer will send to ROV and it will activate the MCP. Then this MCP will activate HCU, TCU camera and sensors. At the same time, it will also activate the transformer at ROV, which will step down to activate the light. The power supply from genset will also supply 480 volt AC into two transformer, this and this. So this voltage from transformer will send to two motor at ROV. The ROV motor require 1200 volt AC motor, so they need to have two transformer at the control van to step up. And the next, the power supply from genset will step up into 1200 volt AC and send it to motor at TMS. Also the power supply from genset will step down into 440 volt AC and send it to the junction box at TMS, which will then be transferred into MCP and transformer. So the MCP at TMS will activate the altimeter, camera, sensor and valve pack. Also at the same time it will activate the transformer at TMS, which will step down to activate the light. Also the power supply from genset will supply 480 volt AC into motor at HPU to activate the hydraulic system. First, we have electrical motor that power up the hydraulic pump. From there, it goes to high pressure filter. This is to filter out contamination in the hydraulic oil because we don't want contaminants to spread and stuck in the solenoid or servo valve. From high pressure filter, we go to two position four-way servo valve which can guide the thruster. Why do we use the servo valve? This is because servo valve is precision control and it is not like solenoid valve which have 1 and 0, which means it is can just go or stop like on and off. So from the thruster, the line will return and go back to HCU. From there, it will go to 5 functions manipulator. So why 5 function manipulator? Use this solenoid because uh, one have task because it have one task per line, which means such as jaw open, jaw close, elbow move right, elbow move left, etc. That's why it does not use servo valve. Then from manipulator, it will return to water filter. Why water filter? Because in case if there's any leakage or water goes inside the hydraulic line, we don't want it goes to the main compensator, which contains storage or reservoir for hydraulic oil. Then from the main compensator, it will recycle back to hydraulic pump. There is also a mechanical compensator here because in case if there is a pressure loss in the thruster system, the compensator will compensate the loss. However, it can only compensate minor loss, for example, 3-piece eye only. If it is more than that, then it is considered as a major loss and ROV need to be stopped and pull out. I would like to finish my presentation. Thank you for your kind attention.